Everyone. It's a great pleasure for me to be here with you today. It's a great pleasure for me to be here with you today. Thank you very much for the scientific committee for the opportunity to present the work entitled "Based on Encapsulation System Fertilizer in Sustainable." Let me introduce myself. I'm the Hanai student in polymer engineering at the University of Bijaya. I'm doing my research in the area of advanced polymer materials under the supervision of Professor Dalila and Professor Wilson Case from the University of Technology, Binjai. My presentation is structured as follows. I begin with a short background and our motivation of our work. Then I will describe our main idea and concepts, followed by some characterizations, and I finish the finding and perspectives. In recent international agricultural practices, I faced several limitations, including excessive water load, need for large cultivators, and overuse of chemical fertilizers, all of which negatively impact both soil quality and the environment. To overcome this challenge, work propose an innovative and systematic approach that aims to reduce the amount of fertilizer, minimize the cultivation area, and control the release of nutrients into the soil. For this purpose, we designed eco-friendly hydrogel based on biodegradable polymer that efficiently retain and water. This hydrogel is a smart carrier for fertilizer, ensuring their and controlled release according to the plant's needs. Our concept is by the idea to help another plants. The first step of our work is the green synthesis of particles using mango leaves. After optimizing the matrix with the backbone polymer acrylamide like ammonia, we incorporate particles in hydrogel matrix before steps. Obtained hydrogen nanoparticles was swirled in a solution to study their fertilizer encapsulation and control release. Try to focus our smart hydrogel can both improve fertilizer efficiency and sustainability protect plants, while outside nanoparticles reinforce the hydrogen matrix, improving the mechanical and stability. So nanoparticles also possess strong antimicrobial, which helps to protect us against harmful microorganisms. They also support the photosynthesis process, contributing to plant growth and leaves. We use area fertilizer. It's one of the most and nitrogen rich. Contains up 46% nitrogen. We select Kite because it's a biodegradable and also has microbial properties. It has a high water absorption capacity, which makes excellent material for moisture in the soil. To achieve our goal, we do several characterization evaluations. We start with optimization of the preparation parameters, observe that percentage, different factors such as monomer concentration, initiator concentration, concentration, and volume of solvent, time of the process, and wave power. Basically, are the analysis, the characteristic like theta equal 5 degrees, 48 degrees, 61 degrees, confirms the second size of serum nanoparticle. In addition, physics analysis shows the presence of copper oxygen element, further confirming the purity of serum nanoparticles. XRD confirmed the grafting of acrylamide into the backbone, with a decrease in crystalline compared with pure ketone, which indicates grafting reaction. Also, XRD gives us confirmation of incorporation of CO nanoparticles into the chitosan matrix, and the degree of increases with loading of CO nanoparticles. The IR analysis reports and conflicts are the results both drafting of acrylamide and for the creation of CO nanoparticles to hydrogen matrix. At the same time, IR also confirms the absorption area filterizer in hydrogen. Evidence by the appearance of the NH binding around 1060 centimeter -1, also and stretching around 1400 centimeter -1. This clearly demonstrates the sequestration of the composite on hydrogen and effective of area within its network. Let's move to properties. The control hydrogen has the highest swelling, while the incorporated nanoparticles slightly reduces the swelling capacity. The uptake capacity of various hydrogen formulations evaluated after 20 hours of immersion in 1000 ppm area solution. The hydrogen 2% CO nanoparticles the best balance between and area. About scanning electron microscope, our hydrogen without nanoparticles rough and porous surface indicative of water absorption capacity. With nanoparticles show denser and more compact with reduced mass. The hydrogen nanoparticles in area without nanoparticles reflect a swelling slightly roughed surface with visible enlarged pores. Our hydrogen with nanoparticles in area conditions, light surface, the particle. The antimicrobial process of our formulation of nanoparticles, hydrogen without nanoparticles, the hydrogen with nanoparticles was evaluated using two standard bacteria, gram-positive and gram-negative. All showed strong microbial activity produced clear. In the end, very successful developed an eco-friendly biodegradable hydrogen system based on acrylamide reinforced with degree nanoparticles. The creation of these nanoparticles not only improve the mechanical and structural stability of the hydrogen, but also provide antimicrobial protection and synthetic enhanced supporting plants. Overall, these materials demonstrate as a sustainable system for fertilizer capable of gradual and controlled nutrients, while efficiently conserving water and reducing the environmental impact of traditional agricultural practices. As a future work is on testing the system in soil conditions, evaluating its long-term biodegradability, and exploring natural nanoparticle fertilizers to agriculture efficiently further. In the last and most, thank you very much for Supervisor Professor Hamid and Professor Kate, all the members of the materials of Kate, and all thank you very much. Thank you for the National Institute of Technology for their. Thank you very much for your attention. Let me